Welcome back to Lesson 2. In this video, we're going to get our hands dirty with a review of algebraic techniques to solve equations that we've seen in our past lives. Let's remember what we said about the algebraic technique to solve algebraic equations from video 1 of Lesson 2. To solve an algebraic equation using an algebraic technique, our motto is isolate the variable using inverse operations. Get the variable by itself on one side of the equation. The other side should just be a plain number, variable equals value. So we've gotten the variable isolated, and we did so using inverse operations. The one thing that we said was the algebraic technique depends on the type of equation that we solve. Let's take a look at an example of a problem that we might see in an algebra class. Use an algebraic technique to solve the equation x minus 6 equals 3 times quantity 2 minus x, n quantity. Before we do anything, I'm going to encourage us to get in the habit. Here's some math stuff. Ugh, God, hideous, ugly, painful. Bunch of math symbols on the page. There's a math statement. We're going to ask ourselves a simple question. Is there an equal sign? Dun, dun, dun. Yep, there is. This is an equal sign. The moment we see there's an equal sign, we're going to call this thing an equation. What do we do to equations? We solve the equation, so we know we're going to be looking for a solution. We're going to remember that the solution is going to be in the form variable equals value. We're going to be working our entire little booties off to get this thing so that the x is by itself on one side and there's a single number on the other side. Moreover, we're going to ask ourselves, what type of equation is this? Well, let's go ahead and analyze the left-hand side of the equation and the right-hand side of the equation. On the left, we have x minus 6. On the right, we have some crazy stuff going on with a multiplication and subtraction. Not a quadratic because no square shows up. Quadro is square. Quadratic is a square. Not a rational because there's no ratio going on here. No absolute value bars. There's no power happening there. And there's also no radical symbol. We're left with the conclusion that maybe it is a linear equation. We're going to solve this linear equation. The first step that we work with, just like we did in expressions, we're going to write the original equation in our own handwriting. That is a very, very good habit for us to get into. Now we're going to write an equivalent equation by doing some algebraic work. And the first bit of work that we see is that this multiplication can be passed through that subtraction because we make it rain. We make it rain. All right. So here we're going to go 3 times 2 minus 3 times x. What do we know about the number 3 times 2? Well, that must be 6. And then here we've got 3 times x. Now the question is, what would we have to do next to get the x by itself? I could do one of two things. I could bring the x over on this side or bring the 3x over to the other side. I'm going to say to this little negative right there, get out of my life. My life is better when you're not around. You know? So here we go. Negative 3x plus 3x. Those go away because that equals 0. X plus 3x. Well, I have 1x. I add 3 more of them. There must be 4 of them. And really what's happening there is that I have a 0. But we know that 6 plus 0 is just 6. And that's why we generally don't have to write that, because right there we've done the inverse operation of subtraction. Addition is the inverse operation of subtraction. Well, what's the next step we might do? There's that stupid negative again, thing trying to mess up my life, you know? So I'm going to say, to get rid of a subtraction, I do an addition. Anything I do on the left-hand side of the equation, I should also do on the right-hand side of the equation. What do we say about minus 6 plus 6? That's 0. And then we generally say that 0 plus 4x is just 4x. And that is why a lot of mathematicians skip this step, because they say, oh, well, 0 plus anything is the thing you start with. But I like to be really clear. The reason that that's 0 is because we have inverted that subtraction. We say that 6 plus 6 is 12, especially on a Tuesday. So now we've gotten the x's on one side, the numbers on the other side, but there's still that stinking 4 in the front of it. This is where I like to have my students be really, really explicit about what operation's going on there. That's 4 times x. So if I want to get rid of that 4, what do I have to do? What's the inverse operation of multiplication? Ding, 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 ding. Division. 4 divided by 4. In an equation, anything I do to the left-hand side of the equation, I must also do to the right-hand side of the equation. Now we say that 4 divided by 4 is 1. 1 times x, and 12 divided by 4 is 3. We also know that 1 times x is just x. Now we've gotten it down into our desired form, variable equals value. We have not yet checked this work. I'm not going to box the darn thing until I check my work. Remember, we said that a solution was a value of the variable that made the original equation true. Let's go ahead and drop x equal 3 into each side. Everywhere I see an x here, I'm going to just go ahead and put a 3. I like to put parentheses to say I'm evaluating this at x equal 3. And then we're going to have a question mark. Is this equivalent to dropping a 3 on the other side? We know that 3 minus 6 is negative 3. Here we've got 2 minus 3. That would be negative 1. And then negative 1 times 3 is indeed negative 3. The left-hand side equals the right-hand side. That equation is true for the value x equal 3. Thus, we have confirmed for ourselves that the value that we settled in on is indeed an equation, and we did check our work. So I box it and I check it. I want to give a call out. I wrote the original equation down. I connected equivalent equations. Here I have my original equation. Here is an equivalent equation. It's the same equation in different form because I've distributed. The connection between equivalent equations is done with this little double arrow. This is called an implication sign. And I want to call out, it's not an arrow. It's not like that. No. It's 2 lines and an arrow. It's called an implication sign. And notice each of my equivalent equations is connected with a separate implication sign. And I'm working vertically down the page like we recommended previously. There's plenty of space in between. I've also boxed the final value once I checked it. Super good habits to get into. The last thing I want to recall, before we started this actual mathematical work, we did a few things for ourselves. One, we asked ourselves, is there an equal sign? Because there was, we called it an equation. We solve equations, which means we produce a solution which is in the form variable equal value. We also asked ourselves, what type of equation was this? In this case, it was linear. When we were using inverse operations, we noticed we only used 2. We used the idea that addition undoes subtraction, and then vice versa, subtraction undoes addition. We also use that division undoes multiplication. That's the only inverse operation that we used in this entire set. Let's take a look at another example using the same kind of ideas.